So hello everybody. Okay. So we'll continue from this point where we left. That is some examples of equal sets. Set E sort of letters in the word follow and this. So clearly A and B has exactly same elements, and we can say that A and B are equal. Now, if we go through uh, some other example, let us say example of 4, we are taking. A is equal to x such that x belongs to natural numbers and x square minus 9 is equal to 0 and b is equal to x such that x belongs to z x square minus 9 is equal to 0. In this case, if you see, so one doubt you can have, what are the symbols? So let me clarify that problem. One doubt you can have. So Z is generally use Z as we'll say Z can be used as an integer. Okay, so a the number of elements for this natural numbers it is x minus 900. So obviously it is 3 is the answer. So and for natural numbers and for z it is minus 3 and 3 both because integers can be negative also. Hence these two sets are not equal. So logically we can understand two finite sets A and B are said to be two finite sets A and B. There's two finite equivalent sets. Two finite sets A and B are said to be equivalent if number of elements of A is equal to number of elements of B. So it all depends on the number of elements, right? So finite sets A and B are said to be equivalent. Equal sets are always equivalent, but equivalent sets need not be equal. So there is a slight basic concept behind this. In case of equal sets, two non-empty sets are said to be equal if they have exactly the same element and we write A is equal to B. So whenever we are saying A is equal to B and they have same elements, in that case we will say it is a equal sets. And elements will be same in the case of equal sets. Elements means all the elements will be, ordering is not important. The elements are equal, then it will be equal sets. If the number of elements are equal, that is Na is equal to Nb, so we'll say it is equivalent set. It is not equal because the elements are not, we're not considering, the counting we're considering. So we should be very clear on that. The counting we are considering, not the elements. Hence, a set can be equal. Now, obviously, it is equivalent. If an equivalent set is there, so it is not to be equal in that case, right? So in the example number 1, A and B, we have 1, 3, 5, and B, we have 2, 4, 6. So these two sets are, we can say, are equivalent in nature, uh, right? A and B are equivalent, but A and B are not equal in nature because elements are different in this case, right? That is the logic we can easily use. Okay. So further, if you just progress it further, phi 0 in bracket and phi are not equivalent. The logic we can give is 0 in bracket, if I write it is having one element, and phi is not a set, b is equal to phi. So in that case, I will say number of elements here is 1 is 0 here, that's why it is not equivalent. Okay. It's a very, very good example being taken here. One more example was there, yeah, all different. Phi is a set of set containing no elements at all. So it is a set having no elements. And 0, when we keep in bracket, it is a set with one element, that is 0. Hence, it is not equivalent nor equal. Both the things are possible here. So let us move ahead. Subset. A set A is said to be a subset of set B if every element of A is also an element of B, and we write A is a subset of B. In this case, every time we just try to write a small line here, so it is a subset of B, so that if A is a subset of B, then B is called the superset of A, or we can say B is a superset of, in the opposite way we can write, and proper set if proper subset if A is a subset of B and A is not equal to B. A is not equal to B means the elements are different. Then A is a proper subset of B, and we can write A is a proper subset of B. In place of proper subset, we'll just not use the line below. If there exists even a single element in A which is not in B, then A is not a subset of, and we write. So, okay, if there is a single element in A which is not in B, then A is not a subset of B, and we write A is not a subset of, not a proper subset of B. There are examples. With the help of examples, we can easily confirm it. Examples of subset, let us say example A is having a set is there with 2, 3, 5 as the elements, and here we have an extra element. So A is a proper subset of B, but A is not equal to B. Okay, is a proper subset of B. In this example, A is having two elements and B is having a different. So neither, in this case, neither A is a subset of B nor B is subset of A. Nothing can happen. So results of every set is a subset of itself. Every set is a subset of itself. The empty set is a subset of every set. Total number of subset of a set containing n elements is 2 to the power n. If there are some sets under consideration, then there happens to be a set which is a superset of one of the given sets. Such a set is not the universal set of set for all those. We shall denote by U. So superset of each of the given sets. So super subset of a set R for real numbers, and the values is a set of natural numbers. W is the set of whole numbers. Z set of integers. Z plus positive integers. Z minus negative integers. Q is a set of rational numbers, and T is a set of all irrational numbers. As we've seen earlier, we'll just review it. let A and B two sets, then prove that then we have to let us prove that A is equal to B, then A is a subset, proper subset, subset of B and B is subset of A. A is having elements as 1, 2 is a, which of the following are incorrect statements here, so 2 belongs to A. It contains 4 elements, namely 1, 2, this and this. So 2 belongs to A, then the correct statement will be 2 subset is belongs to A. So here we are saying that in the second question, we have a, there's some learning can be there. We have elements as 1, 2 in braces and in brackets. So we have 3, comma 4, comma 5 is again a bracket closed condition. So 2 belongs to A, which is wrong thing, which is false, I will say, because 2 is in brackets, is a subset of A, they are saying, is a proper subset. So for proper subset, is a proper subset of A. So if it is in brackets 2, it's a proper subset of A. 2 is not a subset, does not belong to A. So in this case, second one in brackets 2 is a proper subset of A. Initially it looks like, but we have to keep in brackets everything. 2 is not equal to A. So 1 comma 2, 2 in bracket is a proper subset of A. So we need to write there again a bracket. So 3 comma 4. 3 comma 4 is a set form, is a proper subset of A. Now in this case, whenever we are saying this, clearly it is an element of A, we can say. The proper subset of is incorrect because we write in the form 3 comma 4 in bracket, again a bracket, then it's a proper subset of A is correct. So writing one more bracket is correct. That's a new thing to learn, we can say. For the sixth one, phi is not a subset of A. Phi is a subset of A is incorrect, while phi is subset of A. So phi is a proper subset of A. Phi in brackets is a proper subset of A that we can't say right now. Incorrect it is, while we have phi belongs to or is a proper subset of A. Phi one is a proper subset of A. So you need to put the brackets here, nothing else. Proper subset 2 is not a subset of A and 3 is not a subset of A. So 1, 2, 3, 4 belongs to A is incorrect. 1, 2, 3, 4, you can say belonging or you can say proper subset of A is incorrect. Why it is incorrect? Because 2, comma 3 we don't have in that form, while we have in some other form. That is a logic applied here. Operators, so it will be A union B, exercise that X is equal to A or belongs to B. Intersection, so that X belongs to A and X belongs to B. So let us say we have A, B, and C defined, so A intersection B and can be done very easily. Symmetric difference of sets. For any sets A and B, the difference A minus B is defined as the so difference of sets. So in this case, difference of sets for any sets A and B, their difference A minus B is defined as X is such that X belongs to A and X is not a subset of B. So difference of sets X belongs to A and X is not belonging to B or learning will hamper here. Different subsets we have discussed. Now the last example is example 22 or 12. We will just have a look